I believe that you are prepared enough to be offered some tips. Because if I just gave you tips before, they would have no meaning. So reminder, we're still doing the same thing. We're trying to determine if infinite series converge or diverge. We have many tests for this because there is no one simple test that does it. Unfortunately, the nth term test lets us down. The nth term test will tell us if something diverges, but it won't tell us if the alternative converges, happens or not. It's inconclusive, which is not particularly helpful. But I think that these tips from students past are beneficial observations. So the first one is a recommendation I wholeheartedly endorse. I endorse considering the nth term test first. You may have noticed the practice is designed that way. Did you catch that? I'm trying to steer you in a direction that's helpful. Trying to steer you in that direction. So that would be a tip I have for you, is consider the nth term test. Even if you don't necessarily write out the nth term test in its entirety, it is still beneficial to consider the nth term test. Something else that I wholeheartedly endorse. I personally am reluctant to use the integral test because it takes a long time, especially when they're nasty ones with like parts and substitution and partial fractions and long division, all the other goodies that we've studied. Those take a while. So I recommend considering those tests that are quick, like the p-series and the harmonic series test and the geometric series test. I know the geometric series test can get a little bit hairy, but it is still usually, I think, quicker to look at a ratio of terms than it can be to just straight up try to find an antiderivative. So we have looked at 5 infinite series tests so far. I think you would agree. We've done 5 of them. We're going to learn about a 6th today, as well as do some additional practice. This is the 6th one. This is the alternating series test. And the name is descriptive, but descriptive of what? What is it? It is alternating. Is it alternating days of the week? Probably not. What is it alternating? And before we actually get into the specifics of the alternating series test, I just want to stipulate that the alternating series test is a test more similar to like the p-series and the harmonic series and the geometric series test. So the way I categorize the information is there are tests that work for very particular series, and there are tests that can be used for any series. An example of a test that could be used for any series is, of course, the nth term test. You can use that for anything. But a lot of these other ones you can only use for certain things. Did you notice that you can't use the integral test on just everything? Yeah, you can't use the integral test on just everything because not everything has an antiderivative. So that's also like a special case. Well, I'm mentioning the integral test. I will remind you that you have to do the requirements, the stipulations, the necessary precursors, the items that have to be mentioned first before you apply the integral test. And you don't necessarily need to write a detailed essay about each one, but you do need to state that you have considered those things. Those things are necessary to communicate. But I've made you wait long enough, hopefully built up some excitement, some anticipation for the alternating series test. What is it that's alternating? Have you been wondering? And in order to answer this question, we will look at this series first. That's a series from 0 to infinity, -1 to the nth power. My question to you is, does that converge or does that diverge? Does it converge or diverge? What do you think? And if you're not sure, maybe you should consider the graph. Consider that graph. Now, what does that look like? Or think about the partial sums. What are the partial sums? Now, before I answer the question, I'll just tell you what the answer is. But I would just like to mention that this diverges, and not because it's a wild guess. That's not how I came up with it. I thought about it looking at the sums. So how do the sums work? Well, your first term is 1, right? So the sum is 1. Your second term is -1. So the sum of the first 2 terms is 0. The third term is back to 1 again, because that's, yes, n squared. I'm sorry, n is 2 -1 squared, +1. So the third sum is back to 1 again. The fourth sum, what's that? That's 0. Okay, fifth sum is 1, sixth sum is 0, seventh sum is 1, 0, 1, 0, 1, 0. Or think about the limit as n approaches infinity of -1 to the nth power. Does that limit exist? It does not. It's either 1 or 0. There's no discernible pattern. It's not like a half. It's either 0 or 1. It just depends. So it would be safe to say that that limit does not exist. Would you agree that that does not equal 0? So we know that this diverges according to the nth term test. Yeah, okay. All right, so the alternating series test, if you haven't guessed yet from my very subtle and obscure hint, is we're alternating signs. So our terms will have a positive term followed by a negative term, followed by a positive term, by a negative term, positive, negative, positive, negative, positive, negative, forever and ever, or the reverse is true. So long as you're alternating signs, you have an alternating series. You found a series in your practice, hopefully, that was alternating. Did you write out terms for cosine of pi n divided by cosine of n? Yeah, okay. Why is that alternating? Well, because cosine of pi times 1 is cosine of pi, which is -1. Cosine of pi times 2 is cosine of 2 pi, which is +1. Cosine of pi times 3 is cosine of 3 pi, which is back to -1 to +1 to -1. Now, the denominators are all different, but the signs alternate. So you actually got a taste of an alternating series already. So an alternating series alternate signs. So remember how we looked at the geometric series and we said it has to be geometric to apply the geometric series test? We looked at the P series, we said it has to be a P series to apply the P series test. We looked at the harmonic series, said it has to be a harmonic series to apply the harmonic series test. All of those things, the alternating series test is the same. The signs have to alternate. If we have the signs alternating, we have an alternating series. Once we know that we have an alternating series, the test has 2 components to it. One of them relatively straightforward, although very confusing based on what we study. And the other one a little bit less straightforward. So the one that we have studied already, but is confusing, is this one. Notice how that is the absolute value of a sub n. That's not a sub n. It's the absolute value of a sub n. And this is going to confuse you with the nth term test, because the nth term test says, hey, if I have a series that approaches 0, it's inconclusive. It could converge, it could diverge. Don't know, can't say. But if it's an alternating series, the absolute value of that term is 0, then we are going to have a thing. The second part of the test is a little bit confusing. So it's written as the absolute value of a subscript n plus 1 is less than or equal to the absolute value of a subscript n for all n. I'd like to remind you, because maybe it's been a while since you thought about this, or it did make sense the first time, or hey, how about a reminder anyway? A sub n is the nth term, probably remember that. A sub n plus 1 is the n plus 1th term, or the term after the nth term, or expressed concisely, the next term. So if the next term is always smaller than the previous term, then we have satisfied the second criteria for the alternating series. The alternating series will converge if these two things are true. And we do the test just like we do all the other tests. We set up the situation, we apply the test, and then we explain what the result tells us about convergence or divergence. So make sure all three of these are true. Before attempting to do stuff, i.e. determine convergence. All right, so here's our first one. And I have another tip for you. If you're evaluating these series for convergence and divergence, my tip is there is no harm in writing out a few terms. So if you're looking at this and you're like, bruh, what do I do? What does it mean? What does it all mean? If this gives you an existential crisis, that's a separate class. But if you're confused about what to try here, then try writing out a few terms. So literally write out -1 to the 1 plus 1 power times 1 divided by 1. And then -1 to the 2 plus 1 power times 1/2. And then -1 to the 4th power times 1/3. And think about what's going on here. Like literally write out some terms. See if that helps you process. So this first one is a negative, or is a 1. The second one is a -1/2. The third one is a positive 1/3. The fourth one is going to be a -1/4. The fifth one, a positive 1/5. The sixth one, a -1/6. Looky, we have ourselves an alternating series. The signs of the terms alternate between positive and negative forever and ever. Another way I could do that, or I'm sorry, determine that, is by recognizing -1 to the power of n plus 1 results in multiplying by -1 to an odd power, which is -1, or -1 to an even power, which is +1. Now that I have established that this is in fact an alternating series, I can go ahead and apply the alternating series test, which is going to require me to take the absolute value of everything. I believe that is the absolute value of -1 to the n plus 1th power times 1 over n. It's just 1 over n, yes? And that is 0. Now, this is where things get confusing with stuff we've already learned. It's not the limit approaching 0. That's not the problem. The problem is how this is one of the things that proves convergence. This helps us understand convergence here for an alternating series. We would expect if we were doing the nth term test, and therein lies what we want to pay attention to. And that's why I've been emphasizing so much when you're doing your practice, write down, think about, state, rewrite, mention, discuss. Always go back to which test are you performing. It's the clarity of knowing which test you're performing that's going to assist you when things get murky. when things are murky, or they're a little bit musty per se. You have a bit of an issue determining what to do. And things get real musty real fast when you're taking an assessment, I think. Right? That's when you start getting musty. Yeah. Get musty when you take that examination. So remember that we are doing the alternating series test. So saying that this approaching zero helps us show convergence is perfectly reasonable and fine. That is okay. So what do we do from here? Well, we do from here this part. Now, you can, several ways of approaching this. We can, again, write out terms. We can think about some of those terms. So if we go back here to where I've written terms, and we think about the absolute value of these terms, and we compare 1 to 1/2, well, 1/2 is smaller than 1, right? Yeah. What's after 1/2? 1/3 is 1/3 smaller than 1/2? Sure. Is 1/4 smaller than 1/3? Yep. 1/5 smaller than 1/4. We could do it conceptually to say we are taking 1 and dividing 1 by increasingly larger pieces. That's a smaller fraction each time. So there are different ways of doing this last part. And you want to come up with one that makes sense and works for you. Here's another one. We can do it algebraically. Check that out. Check out that sweet algebra. Look at that. Cross multiplication. Woo! 1 times n plus 1, that quantity is n plus 1. 1 times n is n. Would you agree that for all values of n greater than or equal to 1, n is less than or equal to n plus 1? For sure, because it's always one bigger. It's always one bigger. So it would be safe to say then that this is the case. The series n goes from 1 to infinity of -1 to the nth power times 1 over n converges according to the alternating series test. Giving you a couple of other ways of explaining what's going on there. You certainly don't have to use the algebra unless you really want to. While you're writing the next example down, what I want you to remember is that there are 6 infinite series tests to consider. And right now you may be like, oh, it's an alternating series because we're doing a lesson on alternating series. And that's true, but that doesn't help you when you take your exam. Your exam isn't like, hey, this is the alternating series section, guys, right here. Bright lights, shiny things, dancing and singing. It doesn't like tell you that. You got to figure that out. So make sure you don't take for granted that this is an alternating series. Go through the reasoning process. Take a look at the information you have. Use that to guide you. Because maybe I snuck in one and this is an nth term test or an integral test. I mean, it could be an integral test, right? This would be a long division, doohickey. Yeah, n plus 1 and n have the same degree, so we'd have to do n divided by n plus 1. Yeah, for all you know, it's an integral test. So make sure you know for certain. You don't just take for granted that it's an alternating series test because I'm here making you feel really good about math and explaining things and doing all the heavy lifting and thinking. Make sure you take time and invest it. So how might you know that this is an alternating series? You could look at this and say -1 to the n. -1 to the n, when n is 1 is -1, when n is 2 is +1, when n is 3 is -1, when n is 4 is +1, when n is 5 is back to -1. That's going to alternate signs. And n over n plus 1, that's always positive, yes? When n equals 1, this is positive. When n equals 2, it's positive. When n equals 3, so I have a negative times a positive plus a positive times a positive plus a negative times a positive plus a positive times, so it's going to be a negative, positive, negative, positive, negative, positive. And it's also okay if you have a positive, negative, positive, negative. Just has to alternate signs, positive to negative or negative to positive for every single term. If it stops doing that, or it's not that exact alternating pattern, then it's not an alternating series. So This is one of my other tips for you besides trying the nth term test and trying the tests that are quick first. Here's another one. Write out some terms. Get a feel for what's happening. I like writing terms. It gives me a feeling for what's happening. That formula, kind of hard for me to process sometimes. Maybe it is for you. I don't know. So what do you think? Looks like it's alternating. Yeah, it's alternating signs from negative to positive, isn't it? It for sure is. So what is the next part of the alternating series test? Well, we want to take the absolute value of the nth term. So the absolute value of -1 to the n times n in the numerator, n plus 1 in the denominator. That's what we want to do. And when we do that, the absolute value is n divided by n plus 1, yes? So we're going to use L'Hopital's rule. And we get 1. We're going to get 1. Since we got 1 for that, we're going to stop using the alternating series test right here, right now, because that first thing was false. Does not equal 0, the absolute value of the nth term. So we know that this alternating series diverges. We know that our alternating series diverges here. Remember, don't get sloppy with your limits. Take time to make sure that you're thinking limit thoughts, even if it's a limit thought you haven't had for a while. Okie dokie. I hope you did not take for granted that this is an alternating series. You actually did some processing to make sure that it is for certain an alternating series. It is. However you did that is probably fine. If you want to clarify that with me later, let me know. Now, this is going to equal 0. So if you're struggling with this factorial idea, remember what factorial means. Factorial means we're multiplying by numbers. And then when n goes up, you're multiplying by a bigger number each time. Okay? So you may have gotten a taste of this earlier before, but I just want to point out that imagine if you had n to the 10th power in the denominator. So you'd have 1 times itself 10 times, then you'd have 2 times itself 10 times, then you'd have 3 times itself 10 times, then you have 4 times itself 10 times. Well, factorials start slower, but they get really big really fast, because like when n is 10, you're doing 20 factorial. That's 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 factorial. That's a big number. Have you checked to see how big your calculator will go with factorials? It eventually runs out of room because it's too big. It's too big. So this 2n factorial is definitely bigger than x to the 10th power. And if you're approaching infinity with 1 over x to the 10th power, then that's going to approach 0. This definitely approaches 0. Okay. So I would like to be careful with you about the n plus 1th term. I don't want you to make this mistake. When we're saying the n plus 1th term, what we're saying is n becomes n plus 1. So you see how it says 2n? That is going to be 2 times the quantity of n plus 1, which is 2n plus 2. So when you look at the n plus 1th term, you're talking about 2n plus 2 factorial. And if we do the cross multiplication from before, I think you would agree that 2n plus 2 is larger than 2n factorial. Yeah, definitely the case. So I got lazy, I just said the series converges. But we satisfied the 2 pieces necessary for an alternating series to converge. Now, there will be additional series tests coming up. There will be a couple more tomorrow. So please make sure you're keeping up with your practice and doing the things.